Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm going to talk about topic 5, discrete probability distribution. This topic consists of two parts, random variables and binomial distribution. The lesson today I'm going to focus on random variable. So in this first part, I'm going to introduce the random variables, how to distinguish between discrete and continuous random variables. Then I'm going to show you how to construct the probability distribution for a discrete random variable, how to construct a histogram for a discrete random variable, and how to compute the mean, the variance, and the standard deviation for a discrete random variable. So let's get started off with random variables. What are random variables? Consider an example of rolling a fair die. The possible outcomes are numbers 1, 2, 3, 4, 5, and 6, and each of these numbers has probability 1/6. Rolling a die is a probability experiment whose outcomes are numbers. The outcome of such an experiment is called a random variable. Therefore, rolling a die produces a random variable whose possible values are the numbers 1 through 6, is having probability 1/6. So the definition of random variables is a random variable is basically a numerical outcome of a probability experiment, and for convenience, we normally use uppercase letters to denote random variables. For example, capital X, capital Y, capital Z. A random variables can be either discrete or continuous. A discrete random variable is a random variable whose possible values can be listed. The list may be infinite, for example, the list of all whole numbers. And a continuous random variable is a random variable that can take on any value in an interval. The possible values of a continuous variable are not restricted to any list. For example, the number of children that a family can have is a discrete random variable. The amount of water a person consumes in a day is a continuous random variable. Here is another example. Which of the following random variables are discrete and which are continuous? First, the number that comes up on the roll of a die. When we consider a die, the number that comes up on the roll can be either 1, 2, 3, 4, 5, or 6. Those are whole numbers. So this example is an example of discrete random variables. Second, the height of a randomly chosen college student. A random chosen college student might have the height of 5 feet 2, 6 feet, 4 feet 9, 4 feet 11, and so on. So the values of the height of college students are not whole numbers. This is an example of continuous random variables. Next, the number of siblings a randomly chosen person has. Any person can have 1 sibling, 2 siblings, 5 siblings, but they can never have 2.5 siblings. So the number of siblings a randomly chosen person has should be a whole number. So this is an example of discrete random variable. The last example, amount of electricity used to light a randomly chosen classroom. This is an example of continuous random variables. So that was about random variables, how to distinguish between discrete and continuous random variables. Now we'll learn how to construct the probability distribution for a discrete random variable. Let's consider example 2, a fair coin is tossed twice. Let x be the number of heads that come up. Find the probability distribution of x. So when a fair coin is tossed twice, there are 4 equally likely outcomes, either head-head, head-tail, tail-head, or tail-tail. For each of these 4 outcomes, we are going to count the number of heads. For the first outcome of head-head, there are 2 heads. For the second outcome, head-tail, there is one head. For tail-head, there is 1 head, and for tail-tail, there is no head. So if we call x as the number of heads that come up, x can be either 0, 1, or 2. We got 3 possible outcomes. The probability that there is no head is 1/4 because among these 4 possible outcomes, there's 1 outcome with no head. So the probability that x equals to 0 is 1/4 or 0.25. Similar, the probability that there's 1 head that comes up is 2 out of 4, which is 0.5 because we got 2 outcomes out of 4 outcomes with 1 head. And the probability of having 1 head is 1 out of 4, so is 0.25. And the sum of these probability is 1. We can notice here that each of these probability is between 0 and 1, and they add up to be 1. So we have two properties for a probability distribution. The first property is P of x is between 0 and 1 for any x, and the sum of all probability is 1. Definition: a probability distribution for a discrete random variable specifies the probability for each possible value of the random variable. In the example 2, the probability distribution of this discrete random variable is just the table of x and p of x. One of the most commonly seen questions on the exam is how to verify if a table is a probability distribution. So let's consider example 3. Which of the following tables represent probability distribution? The first table, we got 2 columns. The first column is the list of possible value of x, and the second column is the corresponding value of the probability. To verify if a table is probability distribution, we need to check 2 properties. The first property is each of the probabilities should be between 0 and 1, and the second property is they add up to be 1. Here there is one negative value of probability, so this table is not a probability distribution. Table 2, there is no negative value in the probability column, and there is no value that goes beyond 1 in the probability column, and they add up to be 1. So this is an example of probability distribution. Table 3, we can see that there is one value that is greater than 1, 1.02. So this table is not a probability distribution. And the last table, here there is no negative value of probability, and there is no value that goes beyond 1. However, if you add all of these probability together, the sum should go over 1. So this is not a probability distribution. So again, on the exam, if you encounter a question asking you how to verify if a table is a probability distribution, you should have to verify two properties. The first property is each of the probabilities should be between 0 and 1, and the second property is they add up to be 1. Connection between probability distribution. Let's consider example 4. An airport parking facility contains 1,000 parking spaces. Of these, 142 are covered long-term spaces that cost $2 per hour. 378 are covered short-term spaces that cost $4.50 per hour. 423 are uncovered long-term spaces that cost $1.50 per hour, and 57 are uncovered short-term spaces that cost $4 per hour. A parking space is selected at random. Let X represent the hourly parking fee for the randomly sampled space. Find the probability distribution of X. So here, since X is the hourly parking fee for the randomly sampled space, so X can be either $2, $4.5, $1.5, or $4 per hour. So there are four possible outcomes. There are four possible values of X. To find the probability distribution, we must list the possible value of X, then find the probability of each of them. The possible value of X are 1.5, 2, 4, 4.5. We find their probability. The probability that X takes value of 1.5 is 423 over 1,000, which is 0.423, because we have total 1,000 parking spaces. 423 of them are uncovered long-term spaces that cost $1.50. Similarly, the probability that X equal to 2 is 142 over 1,000, because there are totally 1,000 parking spaces, but 142 of them are covered long-term spaces. Similarly, we got probability of 4 is 0.057, and probability of 4.5 is 0.378. So the probability distribution of X is just a table consists of two columns or two rows. Either you can list the value back horizontally or vertically. So here I have a table that the first column, the first row represents the value of X, and the second row is the probability corresponding to the value of X. Now I'm going to show you how to construct the histogram for a discrete random variable. Consider example 5. Construct a probability histogram for a discrete random variable. And in this example, I give you the probability distribution for a random variable. In case on the exam, if you are given a question that they're not giving you the probability distribution, in that case, to construct a probability histogram, you have to first construct the probability distribution. Here I already have the probability distribution, so I'm gonna go ahead and construct the histogram. The histogram, I think in chapter 2, in topic 2, I have already shown you how to construct histogram for discrete random variables. So here on the x-axis, on the horizontal axis, I list all possible values of x: 0, 1, 2, 3, 4, and 5. And since these numbers are whole numbers, so I have to list them at the middle of the rectangle, the boxes. And on the y-axis, I list of the value of probability evenly. So the height of each box represent the probability of the corresponding x value. So that's how you construct the histogram is simple. The height of each rectangle in the probability histogram tells it how frequently the value appears in the population. The most important thing in this lesson is to compute the mean and the variance of discrete random variables. To compute the mean of a discrete random variable, we basically multiply its possible value by its probability, then add the product together. In symbols, the mean of a discrete random variable x, mu of x, is summation of x times p of x. Another name for the mean of a random variable is the expected value, and the notation for the expected value of x is e of x. Let's do one practice. A computer monitor is composed of a very large number of points of light-colored pixels. It is not uncommon for a few of these pixels to be defective. Let x represent the number of defective pixels on a randomly chosen monitor. The probability distribution of x is as follows. And the question asks for the mean number of defective pixels. So to find the mean, we multiply its possible value of x with its probability. For the third outcome, the possible value is 0 and its probability 0.2, so 0 times 0.2. Similar for the second outcome, we got 1 times 0.5, then 2 times 0.2, and 3.1, and add them together, add these products together, we got 1.2 is the mean of this discrete random variables. To compute the variance and the standard deviation, we follow the formula sigma square of x is summation of x minus mu of x whole square times p of x. So to compute the standard deviation of x, we first need to compute the mu of x and then use mu of x to compute sigma square of x. However, this first formula is not commonly used. I recommend you to use an easier way to compute the variance by hand. Sigma square of x is equal to summation of x squared times p of x minus mu of x squared. So to compute the standard deviation, first we'll compute the mean of x, mu of x, and then we multiply the square of its possible value with its probability and add the product together, and the last step is subtract the mean square of x from the sum of the product. And the standard deviation of x is just the square root of the variance. So let's continue on example 6 to compute the variance and the standard deviation. From example 6, we have already computed the mean of this random variables. Mu of x is 1.2. Now we are going to find the variance. So to find the variance, I'm going to use the second formula. I'm going to multiply the square of its possible value with its probability and then subtract the mean square. So for the first outcome, the possible value is 0. So the square of the possible outcome is 0 squared and times its probability, which is 0.2. So 0 squared times 0.2 is the first term, and then repeat that for the other outcomes. We got 1 squared times 0.5 is the second term, 2 squared times 0.2 is the third term, and 3 squared times 0.1 is the last term. And then add them together, then subtract 1.2 squared. We got 0.76 is this, the variance of the number of defective pixels, and the standard deviation is just the square root of the variance. That is everything for today. Thank you so much for watching my video. I hope my video is useful for you to learn statistics. See you in the next video. Bye.